Good afternoon everyone, I am Mr. Thank you for joining me for an interesting video. We're going to show you in this video how you can relate the sine to the hyperbolic sine. Generally, you can relate the trigonometric functions to the hyperbolic functions, and you can do that by means of imaginary numbers. Here we're just focusing on the sine and the hyperbolic sine, but a similar exercise can be done for the cosine and the tangent functions. What I have laid out for you here is what you need to start the series expansion of the sine x and the series expansion of the hyperbolic sine. I've presented these in previous videos, but everything here is coming from the Maclaurin series expansion. If you know the formula, the series expansion for a function which is centered around a equals 0 is a formula such as this. The nth order derivative, 0 coming in, and then you have x minus 0 to the power of n divided by n factorial. This 0 here is meaningless, but this right here is the expansion formula, Maclaurin series centered around 0. You can use for sine and hyperbolic sine to arrive at that expansion. And you know that expansion, you've seen it before. So what are we showing you here in this video? This particular identity will be proven for you. Sine with ix, sine of ix is equal to I, hyperbolic sine x. It's an identity which relates a sine to the hyperbolic sine by means of imaginary numbers. You also need to remember that I to the power of 1 is equal to I square is equal to minus 1, I cube is equal to minus I, and I4 is equal to 1, and then it shuffles. This would be 5, 6, 7, 8, 9, 10, 11, 12. You've seen this. So when you're looking at this, it's equal to that. You're relating the sine to the hyperbolic sine. What you end up doing is putting this ix in terms of that expansion. Sine ix will be equal to ix. This part right here being put into the expansion, you'll have ix. This right here is actually, x to the power of 1 divided by 1 factorial, but you don't need to write that. Minus ix cube over 3 factorial plus ix to the power of 5 over 5 factorial minus ix to the power of 7 divided by 7 factorial, and you would keep going on and on. When you look at this first term, ix is just ix. When you look at the second term, you're getting here an x cube and an I cube, but I cube is equal to minus I, which negates this and makes it a positive. You have positive ix cube over 3 factorial. That's what you end up seeing coming out from here. Likewise, you look over here, I to the power 5 would be this term right here. This is 1, 2, 3, 4, and then that would be 5. I to the power 5 would be equal to an I, but you have an x to the 5 over 5 factorial minus. Now look at this, I to the power of 7 would be this term. 1, 2, 3, 4, 5, 6, 7. You're looking here at this term. I to the 7 is a minus I. That minus negates this and becomes a positive I x to the 7 over 7 factorial, on and on. All of this is equal to that. But when you're looking at this, there's a common term, I. You can isolate the common term, and then what you have left is basically x plus x cube over 3 factorial plus x to the power of 5 over 5 factorial plus x to the power 7 over 7 factorial, on and on and on. But all of this right here looks exactly as the expansion of this. So you're essentially looking at I hyperbolic sine x. This right here is equal to this right here. As you've seen it, the identity is true. This sine ix is equal to I hyperbolic sine x. So here we have easily related the sine function to a hyperbolic function using particularly this, using imaginary numbers. But likewise, I said before earlier, you can do a similar exercise for cosine and tangent. You would just start with their individual series expansion using the Maclaurin series, and then you would do exactly a similar exercise as you've done here, and you would take it through. You'll end up proving the identities. Here we're just looking at this, sine ix is equal to I hyperbolic sine x. Have a good day. Thank you.